Here we have a problem on exponential equation. In the given exponential equation, we have to solve for x. That is, we have to find the value of x. Okay, in the given exponential equation, I find 2 to the x power and 2 to the x power over here. So to make the solving process easier, I'm going to assign a new variable for this 2 to the x power. That is, let y equals to 2 to the x power. I assume this 2 to the x power equals to y. So in my first step, what I'm going to do is I'm going to plug in this y for this 2 to the x power over here. So then we get y positive y negative, and the evaluation of this 2 to the third power is just 8 over 1 over 4 positive. So here 3 and a fraction 1 over 2 is 1 over 2 is multiplied. So whenever a fraction and an integer are multiplied, usually we multiply the value over here by the numerator of the fraction. So 3 times 1 is 3, then we get 3 over 2 equals to 32. Okay, so here in denominator we have addition of two fractions. So whenever I want to add or subtract two fractions, I must have the same denominator for both the fractions. So here the denominator of the first fraction is 4, the denominator of the second fraction is 2. So when I multiply both numerator and denominator of the second fraction by 2, I'll be getting denominator 4 for the second fraction, so that I'll have the same denominator for both the fractions. So now I multiply both numerator and denominator of the second fraction by 2. Let me do it. So okay, now let me continue over here. So here y positive y will become 2y negative 8 over, so 1/4 positive, so 3 times 2 is 6 over 2 times 2 is 4 equals to 32. Okay, now what I have to do is I have to solve for y in this equation. So once I solve for y, it can be replaced by 2 to the x power, and I can solve for the original variable x. Okay, let me continue over here. There is 2y negative 8 over. So here we have addition of two fractions with the same denominator 4. So we can take this 4 as a common denominator. So once I take the 4 as a common denominator, I have to add the numerators 1 and 6. When I add 1 and 6, I'm getting 7. So the simplification, the addition of the two fractions 1 over 4 and 6 over 4 equals to 7 over 4 equals to 32. Okay, now 2y negative 8. That is, I'm taking this numerator as it is. I'm going to change this division as multiplication. So when I change this division as multiplication, I have to get reciprocal for this fraction 7 over 4. Then it will become 4 over 7. So equals to 32. Okay, now as I said earlier, I have to solve for y. For that, I have to isolate y. So for that, I have to get rid of all the values around the variable y. Okay, first let me get rid of this fraction 4 over 7. For that, I have to multiply both sides of the equation by the reciprocal of this fraction, that is 7 over 4. Let me do it. So I just multiplied both sides of the equation by 7 over 4. This 7 will cancel, 4 will cancel out. And here 4 goes into 4 1 times, and 4 goes into 32 8 times. So I'm getting 2y negative 8 equals to 8 times 7 is 56. Okay, let me write the equation over here. That is 2y negative 8 equals to 56. Okay, my aim is to solve for y. So for that, I have to get rid of this negative 8. So I'm adding 8 to both sides. When I add 8 to both sides, I'm getting 2y equals to, so when I add 56 and 8, I'm getting 64. Okay, now let me divide both sides by 2 to solve for y. So this 2 will cancel. Y equals to, when I divide 64 by 2, I'm getting 32. I've solved for y, but the variable y was taken by us, and it has to be replaced by the original stuff 2 to the x power, because already we know that y equals to 2 to the x power. The original variable is x. Now we have to replace this y by the equivalent stuff 2 to the x power. So 2 to the x power equals to 32. Okay, now we have to solve for the variable x that we have at the exponent. So now it's an exponential equation. So whenever I want to solve an exponential equation, so what I have to do is I have to get the same base on both sides. So once I get the same base on both sides, I can equate the exponents and I can solve for the variable. Okay, here already we have the base 2. So is it possible to get base 2 on the right side? Yes, it is possible, because 32 is a power of 2. 32 can be written as 2 to the 5th power. Okay, let me write 2 to the x power equals to, so 32 can be written as 2 to the 5th power, because the value of 2 to the 5th power is 32. Okay, now I got the same base on both sides too. So whenever two terms are equal with the same base, what we can do is we can equate the exponents. When I equate the exponents, I'm getting x equals to 5. I have solved for x in the given exponential equation. So the value of x is 5.